Welcome to the DIY Honda Garage channel. The DTC P0716, which pertains to the Input Turbine Speed Sensor A circuit range performance, is a diagnostic trouble code relevant for Honda Accord models manufactured between 2012 and 2017. This code is triggered when the Powertrain Control Module, PCM, detects a malfunction concerning the torque converter turbine speed sensor. This sensor is crucial as it measures the speed of the torque converter, sending critical signals back to the PCM for proper engine and transmission functionality. The sensor is located on the outside of the transmission housing, playing a pivotal role in monitoring the operation of the continuous variable transmission, CVT. Malfunctions in this circuit may lead to compromised engine performance, necessitating thorough diagnosis and repair to restore vehicle functionality. The torque converter turbine speed sensor is a vital component located on the exterior of the vehicle's transmission housing. It detects the number of revolutions of the gear on the input shaft, converting this rotary motion into a pulsing electrical signal that is sent to the PCM, the brain of the vehicle's engine management system. Once received, the PCM converts these pulses to accurately determine the torque converter turbine speed. A malfunction in this sensor leads to inaccurate feedback to the PCM, which is crucial for maintaining the proper operation of the CVT. Furthermore, if there are no pulses detected from the sensor while the input shaft is rotating, the PCM determines that there is a malfunction, potentially caused by wiring issues such as an open circuit, intermittent connection, or a short to ground. This results in the storage of the P0716 error code, signaling the need for immediate attention. The potential causes for the DTC P0716 are varied and pertain to several critical components of the vehicle's transmission system. Firstly, the torque converter turbine speed sensor line may be open, which implies that the circuit connecting the sensor to the PCM is interrupted, preventing necessary signals from being transmitted. Secondly, a short to ground in this line can cause erroneous signals that lead to improper reading by the PCM. Thirdly, the sensor itself can fail due to age, wear, or exposure to elements, resulting in the inability to accurately monitor the turbine speed. Lastly, it is possible for the PCM itself to have internal circuit failures, leading to incorrect interpretations of the sensor data. It is essential to evaluate each of these potential causes systematically to isolate the root issue effectively. When the DTC P0716 is triggered, several observable symptoms may manifest, directly influencing the vehicle's operation. One of the most significant symptoms is the illumination of the malfunction indicator lamp, MIL, on the dashboard, which serves as a warning to the driver. Additionally, the AT gear position indicator will begin to blink, indicating issues with the transmission system. Drivers may also notice poor transmission performance, characterized by delays during gear changes or irregular acceleration behavior. These symptoms collectively signal potential issues with the transmission system, reinforcing the need for prompt diagnosis and potential repairs to ensure safety and functionality while operating the vehicle. Understanding these signs is critical for timely vehicle maintenance. The first troubleshooting step when addressing DTC P0716 involves starting the vehicle's engine to check if the issue persists. Once the engine is running, the operator should drive the vehicle at a speed of at least 19 miles per hour, 30 kilometers per hour, for a duration of at least 30 seconds. This step is significant as it mimics the conditions under which the PCM actively monitors the input and turbine speed sensors. During this time, the technician must remain vigilant for any signs that would indicate ongoing malfunctions including observing the behavior of the vehicle and the transmission system. The act of driving allows the PCM to reevaluate the sensor data, which is essential for diagnosing whether the underlying issue still exists or if it has been resolved. This step is crucial because it sets the stage for further diagnostic procedures if the issue persists. In the second troubleshooting step, the technician must confirm that there are no active diagnostic trouble codes, DTCs, present apart from P0716. This verification process is essential because other existing trouble codes may cause similar symptoms, complicating the diagnosis process. Next, it is crucial to check the vehicle's readiness status to ensure all systems are functioning correctly and can be monitored. If the PCM indicates a readiness state, the technician should then proceed to monitor the outputs from both the torque converter turbine speed sensor and the CVT drive pulley speed sensor. This monitoring is significant as it provides critical data on how these components are functioning in real time, enabling the technician to ascertain if there is a discrepancy between the expected and actual performance. These steps collectively confirm the vehicle's operational status for an accurate fault diagnosis. Upon completing repairs or adjustments to rectify the P0716 error, validating the effectiveness of the repair is paramount. The first step in this verification process involves clearing the diagnostic trouble code, DTC, along with any associated freeze data from the PCM memory, essentially resetting the vehicle's onboard diagnostics. After clearing the codes, the technician must engage in a complete drive cycle to ensure that all systems are operational and functioning autonomously without triggering any additional errors. It is vital to monitor the vehicle closely during this cycle to ensure that no recurrences of the P0716 error occur. This post-repair procedure helps confirm whether the previously identified issue was effectively resolved, ensuring that the vehicle operates reliably on the road. Final verification solidifies the confidence that all systems are functioning effectively. Preventive maintenance is an essential aspect of vehicle care, especially when dealing with potential issues related to the DTC P0716. Regular inspections of the torque converter turbine speed sensor and associated wiring can preemptively identify problems before they escalate. Technicians should also pay close attention to the transmission fluid levels and quality, as degraded fluid can impact sensor performance. Ensuring that electrical connections are secure and free from corrosion will further enhance the reliability of the sensor's performance. Documenting service history regarding repairs and inspections will also aid in troubleshooting future issues, establishing a pattern of maintenance that can prevent recurrence of related trouble codes. These proactive measures contribute to the longevity and optimal performance of the vehicle's transmission system. In conclusion, the DTC P0716 sheds light on critical aspects of the Honda Accord's transmission system, specifically focusing on the input turbine speed sensor. Understanding the implications of this trouble code includes not only diagnosing the problem, but also identifying the core components involved and their respective roles within the system. The troubleshooting steps provide a structured approach to isolate the issue, verify repairs, and ensure the vehicle's performance remains optimal. Additionally, preventive maintenance serves as an effective strategy to sidestep potential malfunctions, prolonging the life of the transmission system. Overall, the comprehensive understanding of DTC P0716 equips technicians with the knowledge to address this issue efficiently and effectively. Please like and subscribe to the channel. See you next time.